All right, so we pick this up and we look at Bohr's model again, but now we have some context. Remember, we left this day of notes and we started talking about these 5 main points, and I added some points with this. So now, once again, we have Bohr's model of our atom right here, and I want to emphasize a few things and a few things that we can add to it from our previous knowledge, our previous day of notes here, okay? And so the first thing that we have is this. Remember, at the center, we still have that real small dot there. I'll make it a little bit bigger for today, but that is the nucleus. Contains our protons and our protons and neutrons on the nucleus, and most of the atom's mass, okay? Now, as we go out, we're going to have the first, second, and third energy levels, which can also be labeled as the orbits, okay? So orbits and energy levels can be interchanged here, and I want to make this point of emphasis, okay? So one, I'm going to label this, again, the first ring is the first energy level. The second ring there is the second energy level. The third ring is the third energy level. And then that fourth ring here is our fourth energy level. And I want to take the time to point out at this specific point that in this model here that we are showing, we are only showing 4 possible energy levels present, okay? There can be many more, all right? I do want to just make that point, is that we only are showing 4 possible energy levels or electrons for that electron to occupy. There could be quite a number more, right? We can continue going on this process. Now, what I want to add to this is as follows, right? And it's kind of an extension where we left off on this portion of notes, is that that first energy level can have a max of 2 electrons, and also out to the side here, the radius was equal to 1 times a sub 0, which that was just Bohr's constant. Then our second energy level could have a max of 8 electrons, It had a radius of 4 a sub 0. Our third energy level had a max of 18 electrons, and it had a radius of 9 a sub 0. And then our fourth energy level here, remember we showed that from previous notes here, had a max of 32 electrons total that could be present there, and it had a radius of 16 a sub 0. Okay, now I want to make another important point here, and I'm going to write it up in the upper right hand corner. According to Bohr's model, the electron can only be in the orbits that are shown here in the rings, and can only have these specific amounts of energy at that orbit. okay? And it's like rungs on a ladder, all right? So let me take some time to actually write that particular statement down. Okay, and I want to make one final point here with this, okay? Having that point like rungs on a ladder, okay? Imagine this. I always think to myself, okay, think of these as like a stair step, right? If you jump off the first step, probably not going to hurt as bad, or you're not going to feel it as much in your body as if you would take a jump off of that fourth stair in that stair. You're probably going to feel it a lot more. So the higher up in energy, or the higher that electron is in that energy level, the more energy it's actually going to contain. It's actually correlated to that specific energy level. All right. Now, let's keep talking about Bohr's model, and let's make a couple additional points. Okay. Bohr's model. All right. We have this. We have Bohr's model and the emission spectrum. So how Bohr got most of his information was this. They excited, or they added energy to hydrogen. And remember, hydrogen only had one proton, still only has one proton and one electron. And as they added energy, they expect energy to be released, and they saw it in the form of light. However, they only saw a few specific lines. They thought that possibly it might have this white light properties where you see all the spectrums, you see all colors of the rainbow. But what they actually found with hydrogen was they found only a few unique colors of light, okay? And so here is what happened. Here is what happened with this. We get this idea of a line spectrum. And so I want to take a moment here to talk about our specific line spectrum, all right? And I'm going to use a couple different visuals here, and I'm going to talk about it in a few different ways, okay? So the first thing that I want to do is set up our rungs on a ladder, right? This is correlated to our particular energy level. And if we had our rungs on a ladder, I'm going to draw it in this portion right here. And we said that this first line, this bottom line, is our first energy level. Then if we drew another, line just a little bit above it, this would be the second energy level. And another line just above that, that would be our third energy level. And just to match the picture we had before, we'd have our fourth rung or our fourth energy level. Okay. Something that they found was this. Okay. As they excited the electron, okay, which we're going to say that hydrogen electrons, which it does in the ground state or in that lowest energy level, it's first going to occupy that first energy level. Okay. As we add energy to it, which I'll show as this blue line, hey, we add some energy to it, and then it gets to that second level. Now, I guess a more appropriate picture here would be this. We add energy and it stops right here at that second energy level. As we do that, we are going to get a unique line. We are going to get a unique line, which I'm going to show just as a highlighted color. We're going to get a unique release of light, which again, I'll just show it. I know it's not pretty here, but we get a unique release of light as it goes from that higher energy level to that lower energy level. All right. And I do want to make a couple of different points. on this. We are adding energy. To this electron. Okay. And so I'm going to write this actually above here. We are adding energy to our electron. Energy is added to the electron. Okay. And as that's happening, the electron absorbs some energy and it jumps to the next higher energy levels. And if it has enough energy, it could go from 1 to 3 or even 1 to 4. We're showing it going from 1 to 2 and then eventually crashing back down. All right, so we have to gain energy in that electron, or the electron technically has to absorb that energy to go to the next higher energy level. All right, now I want to talk about one really, really key point to all of this. All right, and I'm going to make this again a different color to emphasize this, that the electron is going to prefer to be at the lowest energy level so that the electron gives off some energy by emitting light, okay? And again, I'm going to write this down, and I'm going to write this down and make some sense of it. Okay, so again, still correlated with the picture down there. The electron And so the final thing I want to make here with this stuff I've been writing in green is that energy of the light given off, okay, is equal to the difference in energy between those two energy levels. And I'm going to abbreviate between as B/T. Okay. Now, I want to talk specifically about this light here. Okay. And I'll write this in the color orange. All right. So I want to make a few points about our light. So again, the electron prefers to be at the lowest level. And so when it's in a higher level, it gets that added energy. It's going to crash back down to the lower or the original level. And when it does, it's going to give off that light. Now, the light that we see is the difference in energy between those two energy levels. Now, I want to talk about our light. Our light is given off as the electron returns to that original energy level. With our light, as our electron goes to a different energy level, it will give off a specific color of light. Or as it goes from a higher to a lower energy level, it's going to give off that light. Now, last point I want to make here with this slide is that each color of light is one line in what we call that line spectrum. Hydrogen actually has multiple lines in that line spectrum, and it's going to give off a unique footprint that is only unique to hydrogen because that one electron is going up to different energy levels and crashing back down. And when it crashes back down to its original energy level, we see it in some different bands or some different spectrum of light. All right, so we talked a lot here. I crammed a lot of information. Biggest thing to remember is that hydrogen with Bohr's model, they excited it. They added energy. They actually saw 4 different bands of light, just depending on where that electron started from, that first energy level, where it went to. And then as the electron goes back down to the original energy level, it crashes back down. It's going to give off energy in that unique forms of light, which we put all those lights together, and we refer to that line spectrum for that particular element. Okay, so we talked a lot about what's happened here with our picture of the atom and with our particular dealings and inner workings of what is actually occurring here. Okay, I just want to make some final points about Bohr and his work. All right, so 1913, Bohr publishes all his info about electrons have to occupy a certain ring, has to be in an orbit, or what we call an energy level. In 1922, which is extremely fast, he wins a Nobel Prize for this. All right, very, very large information, a lot of information, widely accepted very quickly. Okay, with this, here is what happened. And here's where we kind of leave off for the next day of notes. Bohr model works great for hydrogen. Guess what? Hydrogen only has 1 electron. We add another electron, helium, 2 electrons there, and it doesn't work out. It doesn't work out for our element lithium with 3 electrons, so on and so forth. So now we need a new model of light. So very quickly, lots happening in science here. 1920s, they do an intense work on the electron to figure out, all right, Bohr had a good model for hydrogen, but we need a way to explain other elements. Okay, what happens is this. We are able to develop this quantum mechanical model to explain why Bohr's model didn't work out for helium, why it didn't work out for lithium or any other elements. Okay, a lot of work's happening here. Okay, so our final points here that we have is this quantum mechanical model. Electrons still in energy levels. That was shown by Bohr. All right, we keep that. Energy level closest to the nucleus, lowest in energy. Still done by Bohr. We just talked about that for these sets of notes. Maximum number of electrons in that energy level still given by 2n squared. Okay, still talked about by Bohr. But here's our difference, points 4 and 5. This is where the quantum mechanical model is going to differ from Bohr's model. Energy levels composed of sublevels, and those sublevels are even broken down even further to orbitals. So we're going to take a look there at points 4 and 5 and start to explain the quantum mechanical model of our particular model of our atom. Okay, a lot of information here, a lot of good stuff, a lot of stuff we packed in to these particular slides.